Okay, so we just talked about, today we're solving logs using properties of logs. If we have logs on one side, these are our steps every time. Condense to a single log, switch to exponential form, solve. So in example 1, to condense, this addition becomes what?
Multiplication.
Multiplication. So we get 5x times 2 equals 2. So this is log of 10x equals 2. Now we have written it as a single log. Step 1. Step 2, switch to exponential form. So this is the common log, which means its base is what?
X.
10.
10.
So to switch, it is the base 10. A logarithm
Root
always
2.
equals the exponent.
Or not root 2, actually.
So 10 squared equals 10x. And then we just solve. So to solve, we just solve. So we got to square that first. And then divide by 10. And x equals 10.
Wow.
And we always check. If I plug in 10, do I have something positive here? Because remember, the base and the answer always have to be positive. The only thing that can be negative is the exponent, right? So 10 works because when I plug it in, this is a positive value. All right. Same type problem, same type concept. Condense to a single log first because we have logs on one side. Logs on one side, condense to a single log. So as a single log, this becomes log, what's the base? 6. Now, when I condense this, what do I do with the 2 and the x?
Multiply.
Multiply them. So I get 2x
Equals 2.
equals 2.
Easy money.
So that is step 1. We did it. Condense to a single log. Step 2, switch to exponential form. So it's the base,
Ooh, let me do it.
6. What's the exponent?
Square.
Good. Equals, what's the answer part?
2.
2x. And then we just solve. Well, we got to square this 6 first. So 36 equals 2x. And then we divide by 2. So what is x, guys?
18.
18. Now, we do check. If I plugged in 18, okay, it's positive. I'm good. Make sense? All right, so let's look at some different ones. This one has subtraction, but we still just have logs on one side. So logs on one side, we're going to condense. So what does this become?
X divided by 8.
X divided by 8.
Yep.
Is that correct?
It is correct.
Oh, I thought
But
you were just like
noticed
pausing
that those
because I
people,
did it
well,
wrong.
I paused because those people that are actually taking notes were busy writing. So I was going to give them a moment to catch up.
I have a photographic memory.
That is not the truth.
I feel like we're not doing. I feel like we're not doing anything different.
We're not. You're right. We're not doing anything different.
Hey, go.
So why?
We're just taking what we've learned one tiny step further.
3.
Oh, logs on both sides. I got you.
So you got to multiply it by 8.
Okay, so now we have to switch forms. Once you write it as a single log, we switch forms. So it becomes 4 to the third equals x divided by 8. Well, 4 to the third is 64.
So 64
How do we
times
undo
8.
division?
Multiplication.
Multiplication.
64 times 8
Be
is?
512.
Yeah, it's like 8 to the third. Now, if I plug in 512, it works. Okay, so condense, switch forms, solve. Every time. Now, they are going to get a little more interesting looking, like this one.
I could do this in my mind.
When I condense, what do I get?
Oh, you get log x squared minus 1 divided by 12
Yeah?
equals
you know?
1.
That's
Okay.
last week.
And the reason we know is because subtraction changes to division.
Why?
Genius.
Because logarithms are exponents, and when we did like bases, we subtracted the exponents. Because logarithms are exponents, that's what
Did y'all learn that last week?
Yeah.
I'll
It's
just.
11, bet.
All right, now we
It's 11.
switch forms, so it becomes 10 to the first equals
Next year.
x squared minus 1 over 12.
It's 11%.
You're right.
She knows it.
Well, you're partially right.
B.
Wait, what?
Yeah.
Michael Lance.
Okay, so this is a quadratic that we don't have to factor because it doesn't have a linear term. This is one where we can just take the square root of it once we move this 1 over.
How'd you get 10 to the first power?
Because it's log base 10, it's the common log.
Right.
When there's no base there, it's base 10. So when I switch forms, it became 10 to the first equals the answer part. This is my base, this is my exponent, this is my answer.
Oh, yeah, you're right. I got that.
Okay.
Sorry.
So 121 equals x squared. And when I take the square root of this, I get positive or negative, but I have to be careful here. Sometimes they both work, sometimes they don't. So if I go back up here and check this, if I plugged in a positive 11, do I get a positive out? Yes.
Yes.
If I plugged in a negative 11, do I get a positive out?
Yes.
Yes. So they actually both work.
I'm a genius.
Must be right.
Okay, and finally, number 5 has the exponent in it. So if it's multiplied out in front, we can rewrite it as a exponent. So this becomes log of x squared. The plus turns into times 4. So when I switch forms, I get 10 squared, because it's common log again, equals 4x squared. So 100 equals 4x squared. When I divide by 4, what am I left with?
25.
25. Now this time when I take the square root, only one of them is going to work. Just the positive. That is the only answer I'm going to get here. Because can I have a negative 5 right here?
No.
Okay, so all of those logs on one side. Condense, switch forms, solve. Logs on both sides. You have to set the answer parts equal to each other and solve. So logs on both sides are actually much easier. But we do have to be aware of if they have the same base. This only works if they have the same base. So whenever we have logs on both sides, you just set that answer part equal to each other and solve.
Wait, why wasn't the last one plus or minus 5?
Okay, the reason the last one wasn't plus or minus 5 is because if we tried the negative 5, when we plug it back here, we get log of negative 5. A log can't have a negative base or a negative answer. Okay. So these are logs on both sides. So all we have to do in this problem is set this equal to that and solve. So we set 3x minus 4 equal to 2x plus 6 and solve. Subtract 2x, subtract 2x. And we get x minus 4 equals 6. Add 4, add 4. X is 10.
That's not bad.
Yeah, these are the easier ones for me. We plug in 10 and see if we get positives. If I plug in 10, I get 26 here. If I plug in 10, I get 26 there. Oh yeah, we don't just get positives, we get actually the same number. Okay, so these are common logs, log base 10. And so if these logs are equal to each other, the only way they can be equal to each other is if this answer equals that answer. That's the only way it works. So when we have logs on both sides, you set the answer part equal to the answer part and solve. But this time when we solve, we're left with a quadratic that we can't just take the square root of. That doesn't work because we still have this x. So we have to factor or use the quadratic formula. So first choice would be to factor, and most of the ones we make up are not that. The second choice would be to use the quadratic formula. It takes a lot longer. All right. Ready to see? Good. All right, so that's beautiful.
Plus or minus square root.
Plus or minus square root. B squared minus 4AC
All over 2a.
all over 2a. So if we had to, that's the quadratic formula. We don't have to on this one because it factors. Now, to factor or to use the quadratic formula, the equation must equal 0. Your equation must be set equal to 0. So, first thing we'll do, guys,
I'm sick, Cole. Sorry.
is move this stuff over here. Now, I always leave my squared term positive. So, since it was positive, guys,
But we could have gone the other way.
you can, but you end up with a negative squared term, which is a little trickier to think about when you factor. So, this gives us this. Now, when we factor, the only way to get x squared with integers is x times x. That is the only way to get x squared. So when the leading coefficient is 1, we just throw our x's in there. Now, remember from factoring, you're asking yourself, what did I multiply to get this that I add to get that? Because I'm multiplying to get this last term. Well, it's actually going to be a negative 7 and a positive 2. Because negative 7 times positive 2 is a negative 14. And you see when I multiply these back, this negative 7 and positive 2 gives me that negative 5. So what can you multiply to get this that you add to get that? All right, so now we're factored. But this equals 0. So the only way this product can equal 0 is if this factor has a value of 0 or this factor has a value of 0. What value of x would make this factor equal 0? 7.
7.
What value of x would make this factor equal 0?
Two.
Negative 2.
Negative 2.
So these are my possible solutions, but they both don't work. Do you see if I plug negative 2 in right here, I get out a negative answer? Are logarithms defined if the answer part is negative?
No, ma'am.
No. 7 works for both of them. 7 gives me a positive 40 and a positive 40. This one doesn't. Okay, so that is not a solution. The only solution is 7. Negative 2 is an answer that we get when we solve the problem algebraically, but actually isn't a solution to the problem. That's called an extraneous solution. It's an extra one that doesn't work. Okay? And here are 4 for you to try. These are your you tries. This is where I'm coming to make sure you understand it. So first of all, are there logs on one side or both sides? If it's one side, we condense, switch form, solve. If it's both sides, we set the answers equal to each other and solve. Those are our 2 methods. Okay, you try.
I got one.
Let me see you try. 1, 2, 3, and 4.
Is 5 cubed?